Hello guys, in this video I would like to explain about how to produce a tether diagram in R and RStudio with Openair package. Yesterday we have done a video about tether diagram, and that was in on theory and interpretation of the tether diagram. So if you have missed that video, the link is given in the description of this video. You can go click on the link and watch that video, because if you don't know what is tether diagram and which statistic this tether diagram use and for what purpose we are using this tether diagram, then if you produce a tether diagram in RStudio, maybe that's not helpful. So we are working in the style that we have solid theory first about any topic like tether diagram. I have discussed about from who developed this tether diagram, and then what is tether diagram, and then the structure of the tether diagram, and then when we can use tether diagram. So this is solid theory about this tether diagram, and then you can use R and RStudio to produce a plot for yourself for your data, and then you can interpret because you know the structure of the diagram. So the link is given in the description of this video. Just click and see how you can interpret your results. This is a data diagram which I produced my data, my own data, and I have used various machine learning and deep learning model to produce to project whether multiple climate and temperature and precipitation extremes using these model. Like this is NN, JBN, GRU, LSTM, RF, NN, and SVM. So some of them are machine learning like NN, JBM, random forest, and SVM, and RNN, LSTM, and GRU are deep learning models. So the combination of deep learning and machine learning model for projecting climate extreme, that is precipitation extreme and temperature extreme. So now we would like to decide which model we can use for projection. So these models are used for the reference data or for the baseline data. Like for CMF6, the baseline data is from 1985 to 2014. So we have used these models. To project these climate extreme for the reference data, and then we have used these model to produce the climate extreme from observed data, and then we compared whether which model is better for reproducing the climate extreme for the representation. But remember that you need to train each model. Each model has some specific hyperparameters. You need to tune those parameters. After fine tuning, you can see the performance can be better. Otherwise, if you are using as it is the model, the performance may be not that good. So now this is just the introduction, and let's now do this in R and RStudio. That how you can do this, and just go to R, which is already over. Let's see. As we are doing this in Openair, there is another package that is called Plotrix, and hopefully we will have a video in Plotrix as well. So this is now Openair package. I think better in my opinion, and you need to install this package by using install.packages and Openair. If you have not installed already on your computer, you can check by using library if there is no option. If there is no problem and the system say okay, we have this package, then you don't need to install it. Like just click on this. So this means that I have this package. There is no error. So if there is an error, then you need to install package on this command, and then you can run. Because if you don't run this package, don't import or load this package here, then this will not work. The function will not work. And now then you need to set the path to the data. Where is your data? So my data is in this path, and so you can see to set the path to the data, and then you can read the file because the file is still in this directory. You can see tether diagram at the end. So then you need this file. This is the file which have my data. So read this file, a .csv file. So that is already working. Yes. Now you can see some values of this file like head. Okay, so the data look like this. The data look like this, and you can see tail of the data, last observation of TD. TD is just for tail diagram, so you can name this data with other name as well. So now this is RNNS at the end and NN at the beginning. Now the important thing is to see what format of data is required for this package. So I will show you the data in Microsoft Excel because I cannot show you the whole data in the OR. Just look at this data. So this is my data. This is year and with the month, 4 January, 4 February. That's mean I'm not sure now with the year, but this came 4 of January. I mean 2004 January, 2004 February. I'm comparing this. You can do this comparison for the whole duration, but I have done this data. I divided the reference data into two periods. One is for training, so that's mean from 1985 to 2014. I have 20 years, so 30 years. So I used 20 years for training of my models, the machine learning and deep learning model, and 10 years for validation, or you can say the assessment of the performance of the model. So that is 2004 January, 2004 February, and then 2005 January, and so on. So you will see, yeah, that is 2015 December until this. Now I would like to show the very important thing, that is the data format for the Openair package. When you are using the Openair package, the data format is different. When you are using Plotrix, the data format is different, and this is extremely important to know about the data format for specific package or function. If you are not using the data in their formats, this function will not work. So let's see. So this is the year. This does not matter, but you need to mention this because for understanding of the data. This is observed data, and this start from here. You can see this will be when NN is completed, or you can say stop in the other model. Okay, just look at this here. Okay, so NN is here 15 December and 145 values or 144 values. So this is 15 December, and the observed data is in this column, remember, okay? And this data is for the ANN predicted data until here. Remember that observed data is in this column against the ANN predicted data. You need to put the same observed data for the same duration against SVM, and similarly with other models. So this point is important. You need this observed data. You can see the okay, that is one. You can just copy the first 4 values, and you will see that are same. Just with the top, just copy here, and you will see. Let's look at this 0, 0, and 15.37, 0, and 44.09, 0, 34.77. So this means that you need to put observed data against each model in this column, the observed data column, the same observed data, because the observed data is same. Like you put this with SVM, remember, okay, and from here. And remember that then the next model will be another model, and this data is predicted by SVM. So this column has different data set, like this was predicted by ANN, this is predicted by SVM, and you have to put observed data against this data in this column, the same observed data. So the same observed data against this SVM, and so on. Now you will see JBM. So JBM is this data is predicted by JBM, and this data is again observed data. So you need to put this observed data against each model. Then this function will work from Openair package in R RStudio. So let's see the last model. Similarly, you do for LSTM, and then RNNS from here. So this data is generated or produced or predicted by RNN data, and this data is observed data. You need to put observed data, the same observed data, because you have only one observed data for this particular climatic stream against each model, not only one model, against each model. So this is the data format for this function in ANN. in not in or in RStudio with Openair package. Now let's see how this works. This was about the format of the data. So now let's see how this function works. So this is the function you are using. Taylor diagram, and TD is the data, which is you can see I just mentioned I stored the data from this file in TD, and I check the data at TD. So this is TD now, and this is observed is equal to observed. You can see now if you want to see this data, yeah, this is so observed is observed. Observed is equal to observed data, and mode is equal to mode data. This is the name given to this column. And groups, you want to group this by models, that is models. I mean RNN and so on, like on the top that was ANN, yeah, and then SVM, JBM, and so on. So this will be classified according to this models. Main, if you want to mention something, this is TN10P. So you need to mention. If you want to mention, you can mention this like with the name of this climate extreme, temperature extreme. By key is equal to true. So this will mention key that title is model, and these two are connected. So if you say true, this will plot the legend with the plot. CX is this is text font and font size, that is 20. That will plot small plot or large plot. I mean the dots for each data. So let's see. Let's try with different values. Just try this. Okay, let's close this and see again, so that we can have a plot. We're sure that we have a plot. Yes. So this is now the plot. You can see we have talked about this yesterday. We don't need to talk about the interpretation. We have yesterday, and we have done this standard deviation, and this is the model now. If you say key is equal to false, then you will have no legend. And this is because you mentioned that main title is TN10P, so that's nice if you want to do. And let's try this with key is equal to false. So how we can see. Okay. Let's look at this now. There is no title. I mean, this title, there is no legend. So you need to, if you want this, you can say write that TRU true. So then you have this legend. That's of course important for us to know about which data is which model. So you can see the red color is by ANN, and the blue color is JBM, and this color is by SVM in this one, and the yellow color is RNN, and so on. Okay, now let's try this. Just change this and you will see the plot will be smaller, and also the legend will be very small. So maybe you don't like me, I don't like that plot. Yeah, it's very small and overlapping sometime. Maybe you like this is up to you. So now the dot are small and the legend are very small. Maybe it's not how to say. And you can see also the font size is very small. So also the title and each and everything. So you can increase this, right? Maybe 15 you like, and this can be the middle. Yeah, now you can see the data are better. The values are large everywhere, here, and there. The x-axis, y-axis, and everything like this is normal. And you can see this point. So then you will see large values, much larger values. Just look at this: large, and separated, not overlap, and large values on x-axis, y-axis, and also this lab, x label, y label, and the title. They are each and everything's look like large. So you can see how you can do. So how you can plot very nice plot Taylor diagram for your paper, your thesis, your technical report, and so on, for your assignments, and maybe for freelancing, and so on. So I think this is enough for today. And by the way, remember that you can access to this code by the link which is given in the description in this video. Just click on this. You will be directed to GitHub, and maybe you need password and username. So maybe you need to create an account. Then you will just click and you will have this code. Just copy and change the path to your data and do nothing else, then you can plot such type of nice plots. Okay, so thank you very much, and I think this is enough for today. Thank you very much, and see you with the next video. Perhaps I will do that in the plot rate. Very much, and next video. Ciao.